Hello everyone, thank you for watching my videos. In my last video, we have seen how do we use Ghidra and Drag and Dance plugin to check code coverage on Windows based system. So in this video, we will see how do we measure code coverage on a Linux based system. So since we have source code available on the Linux, we will use some readily available plugin like Gcov or lcov for that. And as you can see on the screen over here, we have our simple C program which we have been using in our past videos. It has a very simple structure over here, that is img, and it contains various fields like character, width, height and data. And then there is a main function. As you can see it over here, it calls process image function, and this process image function will open the file name which we supplied it as a input to the program, and then it will do some sanity checks, and then it will try reading the data in this particular structure, that is struct image over here. So it will try to read header, image width, image height and data from the file, and then it will perform various operation, like it will add width and height over here, then it will allocate some memory, then it will do some operation. So basically it contains a lot of vulnerabilities. And now if we want to fuzz it using any further, then we need to measure the code coverage. So to fuzz a program, we need a good input corpus which covers most of the code path. So in this case, if we get an input which covers most of this code, then there are chances that we will get bugs uh, in any part of this code. But if there is some input which doesn't cover this part, but say if it covers the code part till here, then it will not go inside the while loop and it will not find any usable bug. So we need to discard such inputs. And so how do you check in Linux is that you can simply measure the code coverage, and uh, since we have various utility, so we will simply go ahead and we will use them. So let's go ahead. First thing you need to do if you want to check code coverage is that you need to compile your program with GCC and with the coverage option, so that it will generate the code coverage files for that. And for that you can simply use this command, that is gcc -g -o0 -coverage. So this is the flag which tells GCC to generate the code coverage data, and then standard your C file name and output file is let's call it image read underscore coverage. So it will create a build, and it will actually create an executable file, that is image read underscore cov. And then what we need to do is that we need to generate coverage file. So we need to give each and every input to this compiled executable. So I have two input files. I will show you. First one doesn't contains anything except some header. So I will just show it over here, and header.em. So you can see that it only contains header, that is hello over here, and nothing else. And the second file, it will actually contain some data. So I will dump that. So you can see that it contains hello, that is a header, 4 bytes. Then there is a width of and there is height, and there is some data over here. And now what we will do is that we will measure code coverage for both of this input. So first we will start with the header. So you don't need to do anything. You can simply run image read that compile build, that is underscore cow. So it will generate a coverage file, and we will first see the coverage for this input, and then we will see coverage for the second input. So I think the file is already present, so I need to remove this imagery.gcdf file, otherwise it won't work. So let me remove this file, that is imagery.gc. So every time you want to generate the coverage, make sure that you remove this file. And now let's see. Okay, so if you see, it has generated this img read dot gcdf file over here. And next step you need to do is that you need to use lcov plugin to generate the data in a readable format, in a graphical format if you want to use that. But before that, you need to run a command that is gcov dot slash imgread.c. So this is the source file name, and what it will do is that it will generate another file that is imgread.c gcov file over here, and then we need to use lcov for that. And so first thing we can do is that we can check what does this file contain over here. I will simply do a vi, and you can see that it contains our source file, and there are various uh, data over here, like graph is here, then data coverage data is in this file, runs is one, so there is only one run for that, and then it contains a different line number over here plus the hit count over here. So one means this line has been executed over here, then there is this line was not executed, then again there is a printf, so this line was executed, and this one, so this loop was executed, and you can see there is a dash over here, so these lines were not executed. And now that since this data is not in a proper human readable format, I mean, if you need some graphical data, so for that you can use lcov plugin over here. So lcov has this simple format. You need to type lcov and dash capture dash directory, that is our current directory. So I have given dot over here, and then output file that will be img read coverage info. So what this lcov will do is that it will generate another file that is img read coverage.info, and let's see the difference with this gcov file. So what is the difference over here? I will just use vi to open that file, see what is the difference. Oh, and you can see that it only gives you line number which maybe executed, which is not executed over here, and so it doesn't contain much of the details over here. And now we if you want to generate some graphical data, then you can use lcov plugin. So sorry, you can use genhtml, so it will generate the data in a html file which you can browse very easily. So for that you can use this command, that is genhtml image read underscore coverage.info. So this is the file which we generated using lcov over here, and then you can give output directory, that is out coverage, this outcov over here. So what this will do is that it will create a new directory, that is outcov, and inside that it will create various files. So I will just show you over here. You can see it has generated a lot of files over here, like some png and some html file. So what you can do is that you can use any browser, and you can open index.html, and you can actually uh, go through the code coverage over here. So you can see that this is a nice report, lcov code coverage report. There is a top level, there is a file name over here, and you can see the directory. So we are inside fuzzing directory, and inside that you can see, if you click on that, you will see that there is a file that is imgread.c. So this is our vulnerable C program, and you can see that it's in red over here. So what does it means is that we are only covering 26.5 lines out of total 100% over here. So our coverage is not good since it's in red. If you see our functions, so we are covering all the functions, that is there are total 2 functions, so we are covering 2 out of 2 functions, but lines we are covering only 9 out of 34 over here. So this is not a good coverage, but if you click on this imgread.c file over, you can actually see what are the lines which are covered over here and what are the lines which are not covered over here. So you can see that this line has been covered, it has been covered for one time over here. Then this is the line which is also covered over here, and since file pointer is not equal to null, so this line is not covered, it is 0 over here. Then printf, it actually even reached to while loop over here, but since we did not had any data, we only had header over here, so this check will fail, it will not go inside this file, and so rest of the lines are not covered over here. So this is the code coverage for this input, and as you can see it over here, it is not covering all the code paths. So now what we will do is that we will try it with another input file. and we will see the code coverage for that. So we will remove all the file which were generated, and just to avoid any issue, so I will just remove code coverage info. So remove gcov over here. I will also remove .gcda, but just in case it cause any issue. And now we are going to run this image read underscore cow file with our second input that contains all the data. So you can see pass this as a parameter to image read underscore cow, and as you can see that it has print header width height data over here. So it has generated the coverage file, and again we will use the same approach. Simply use gcov. I will give the source file name over here. So as you can see that total lines which are executed are 88% of 34 over here. And next we will use lcov. So it will generate some data which can use generate HTML reports. And this is the command, and I will give the same file name over here, that is lcov capture directory that is dot. So coverage data is in current directory. Output file name, that is output file image read underscore coverage info, and you can see that it has generated info files over here. And next we will do is that we will simply generate HTML file over here. So we'll use genhtml image read coverage info. So this is the file which lcov generated over here, and we will simply give output directory, that is outcov over here. And you can see that it gives some summary over here as well, but since we are interested in using our browser to view the HTML page, so we'll simply use Firefox. We'll give outcov and text.html. We will figure out the difference. So if you remember in our last video, in our last coverage report, we only had like 26% of coverage, and we are only covering 9 lines. But if you see it over here, it's in yellow now, and it means that we are covering 88.2% of the code, that is 30 out of 34. And again we are covering 2 out of 2 functions. So this coverage seems to be good. And check the time as well over here, and when you click on fuzzing, you will see imageread.c. So in case you have multiple files, those will be listed over here, but since we only have one file, will only display imageread.c over here. When you click on that, you can see that there is a difference, right? So almost all the code paths are being covered by this input over here. You can see that we are able to go in, the second input was able to go inside while loop as well, and you can see that this line was executed one time, this line was also executed one time, this line was not executed because it was not divided, size 1 was not divided by 3. If you add image width and height, that is how size 1 was getting calculated. So this line was not getting executed, and this line was also getting executed one time. So you can see that most of the lines were executed, except I think 2 or 4 lines over here. Yeah, so our second input has a very good coverage. Compare it with the first input, and we are getting a good coverage over. So this is how you measure the code coverage. But as you might have noticed that it requires you to install run a lot of commands like gcov, lcov, genhtml, and that is something which not many people want to do. So there is actually an automated tool which you can use, and that is called Gcovr, that is gcovr, and this is actually a Python tool. So what you can do is that you can use pip to install that. The command will be pip installed gcovr, govr, and it will install this tool for you. And you don't need to do anything except that you just run your input with this and simply run this gcovr tool, and it will really do everything for you, like lcov and everything. So it is hosted on GitHub, and you can go to this URL if you want to install the latest version, that is github.com Gcovr, that is Gcovr over here, and install it over here. So it will actually do all the lcov genhtml work for you. You don't need to write separate command. Only thing you need to do is that you simply need to run the your compiled binary with the input, and then rest it will take care. So if you want to run that, you can simply use gcovr, and let's see what are the options. So as you can see that it gives 88%, it will do everything for you, and you can simply check help over here. So it has a lot of options, like you can generate XML file, you can generate HTML file, or there are various options. You can give it to gcov or others as well. So let's try and use that to see the code coverage. So first thing you can do is that you can simply give a option that is -r, and then you can give dot. So you can see that it gives you a nice output like gcc code coverage report directory file, that is image.c. There are total lines, that is 34, and lines which are executed are 30, and coverage percent is 88%, and missing, so there's line 22 to 23, line 43 and line 84, which are not getting executed over here. And r over here means the root directory, so you can simply give the directory which contains your coverage files over here. In this case, for current directory, so I have given it as a dot. And now let's see how do we generate HTML reports from that. So if you want to generate a HTML report, then you can simply use this option, that is gcov -r or -r, that is root directory, that is dot over here, then --html, --html details, and -o, and coverage.html. So this coverage.html is the HTML file which will contain all the data. So I will just show you what kind of data it will give. And we can simply open this using Firefox. And let me open HTML, and let's see. So you can see that it gives some detail like legend. There is a, if it's in red, then our coverage is less than 75%. If it's yellow, it means that our coverage is above 75%, and high means if it's green, then our coverage is very high. So in this case, since it's in yellow, our coverage is somewhere around more than 75%, that is 88.2% over here. And let's see, so you can see there is some color changes over here. It's in green color, and it gives you some line which are getting executed, which are not executed in red over here. You can see over here, so branch one has taken one time. So you can even see that if you have some if or else condition, then it will give you the detail that which condition is has been taken over here, which is not taken over here. You can see over here that branch one is not taken. So in this case, there is a if condition over here. So this if was not taken, but else was taken over here. And similarly, you can get a lot of data out of that. So if you want to generate code coverage, then you can simply use gcov tool over here instead of doing everything manually using gcov and lcov or genhtml plugin over here. But I have covered both of this approach so that you know how does things work, and then you can use gcov tool to generate code coverage over here. And generating an input which provides you most of the code coverage in your program is a good idea if you want to fuzz any program. So I hope that you now understand how to check code coverage on Linux as well. And please do subscribe and like my videos. That will help me to create more content. Also, if you have any requests which you want to, if you want me to create any new video on a topic, then feel free to write in my YouTube channel's comments or video comments, or feel free to ping me on Twitter, whatever works for you. With that, thank you for watching my video. Thanks, and until next video, goodbye.